let us have another chapter of heat transfer by convection of thermodynamics and heat transfer. For part 1 problem, a 3 meter long and 0.5 centimeter diameter electrical wire extends across a room at 17 degrees Celsius. Heat is generated in the wire as a result of resistance heating, and the surface temperature of the wire is measured to be 153 degrees Celsius in steady operation. Also, the voltage drop and electric current through the wire are measured to be 55 volts and 1.8 amperes, respectively. Disregarding any heat transfer by radiation, let us determine the convection heat transfer coefficient for heat transfer between the outer surface of the wire and the air in the room. The convection heat transfer coefficient for heat transfer from an electrically heated wire to air is to be determined by measuring temperatures when steady operating conditions are reached and the electric power consumed. Let's assume that steady operating conditions exist since the temperature readings do not change with time. And here, radiation heat transfer is negligible. So when steady operating conditions are reached, the rate of heat loss from the wire equal the rate of heat generation in the wire as a result of resistance heating. First, let us determine the convection heat transfer coefficient for heat transfer between the outer surface of the wire and the room. So, since heat loss from the wire wall will equal to the rate of heat generation in the wire as a result of resistance heating, that is, we have this formula. The heat rate is equivalent to the energy generated. It is equals to multiplied these two electrical units. We have for volts 55 volts and ampere 1.8. Now we have heat rate generated in the electrical wire to be 99 watts. For the surface area of the wire, we have here pi multiplied by its diameter and its length. So we have a diameter to be 0.5 centimeter. Into meter, let's convert it. Let's have 0.005 meters. And for our length, that is 3 meters. We have now the surface area of the wire to be 0.04712 square meter. Newton's law of cooling for convection heat transfer is expressed as the heat rate of convection is equivalent to its height multiplied to its surface area and multiplied to the differences between its temperatures. So disregarding any heat transfer by radiation and thus assuming all that heat loss from the wire to occur with convection, the convection heat transfer coefficient is determined to be this one. We now have H is equivalent to the heat rate of convection divided by the surface area multiplied to the differences in its temperature. So plugging in all the needed values, we have 99 watts for our heat rate convection divided by the surface area and its differences in its temperature. And we have our H to be 15.45 watts per square meter degree Celsius. This is now the convection heat transfer coefficient. Note that the simple setup described above can be used to determine the average heat transfer coefficients from a variety of surfaces in air. Also, heat transfer by radiation can be eliminated by keeping the surrounding surfaces at the temperature of the wire. So that's it for our heat transfer part 2 problem under convection. Thank you so much for listening, everyone, and that's all. See you.